So, really quickly, before we jump into the practical use of Vellum, let's quickly talk about the theory. I want to keep it as short as possible. It's called Vellum in Houdini, but actually it's based internally on a technology called XPBD. And XPBD stands for Extended PBD. And PBD, if you remember it correctly, is actually the system we used for grains. And this is why it comes after POPs, by the way, because it's technically kind of the same calculation. XPBD is a point-based simulation that is based on position. So PBD stands for position-based dynamics, and this is what it's doing internally. I don't want to go too deep into the technicalities, but a couple of things explain themselves when you understand that in a weird way, this simulation here is actually kind of a grain simulation. All attributes that we look at later on are actually assigned to the points because the calculation is actually happening on the point level. Now, if we quickly Google this, XPBD, what we will find is this here. There's a white paper where this technique is explained, and then also a couple of interesting YouTube videos that are worth watching. And this is here the technical explanation of the technique developed by some scientists at NVIDIA. And here it is explained that it's very technical. I'm not expecting you to understand all this. It's just for you to see this is actually the technique that Vellum is. It's just not called XPBD, but it is an XPBD system. And in the video, it's probably a bit easier for us mere mortals to understand. This here explains a little bit what's behind the whole thing, so it's worth watching what's going on here. And what you can see here is something we already know from PBDs, and that is that you need a lot of iterations to calculate the relationship between the points. And we have seen this in form of collisions between the points, but it's also true for connecting points in form of a line. And this is actually what's going on as we've seen. So imagine you have those points, those spheres lined up on a line, and then you pull on one, then one by one, the other balls will be pulled as well. And this also happens one sub-step at a time. And this is another thing to keep in mind to understand the whole settings a bit better. And one thing where you can see that, and of course we will talk about all this here in the next couple of videos, but the Vellum solver itself has a sub-steps parameter, which is only set to 1, which is not what we would expect it, but it's actually also just a multiplier to the constraint iterations and the collision passes. So we actually have 100 constraint iterations that happen with every sub-step. And this is what the representation of all these steps is that we had to manually put into the grain setup. And then the same is true for collisions, which here only has 10 though, and not 30 or something. So while we will not have to increase it to 30 or something ourselves, this is already built in the preset. It's just not obvious at first glance because the sub-steps might be 1, but one sub-step means 100 iterations for the constraints alone. So, you know, in practical terms, all of this is not super important, but I think it helps a little bit to understand the theory behind that and what's actually happening under the hood. And it's good for us to know before we go into all these things. This is basically a grain simulation, surprisingly, where it's not so much about the collision of the points between each other, even though this is happening the same way, but it's more about that these points are connected with each other in form of edges, and the same logic applies. Each connection, each relation can only be calculated in one iteration, and this is why you need so many of them. And the second thing why it's important is keep in mind all this calculation here, even though it might at first not be obvious, is actually happening on a point basis, not on faces, not on edges, but on points. So just keep that in mind. And now let's actually stop the whole theoretical thing and jump into the practical part. And what you will see is working with Vellum is a joy. It's the latest technology in Houdini that was implemented the latest. It took a while to actually for Houdini to have a good soft body simulation system. And when Vellum came around, this completely changed because Vellum is amazing. It's the easiest to understand in my opinion, very enjoyable to work because it's very predictable. Very often in 90% of the case, you try something and it comes out the exact same way you would expect it. So it's very logical and you can play around with a lot of settings and often get good results easy and quickly. So you will, I think, enjoy the next chapter. It's really the most enjoyable, I think, in the whole world of Houdini. So let's stop with the whole theoretical thing and jump right in. And I would recommend to experiment around a lot with Vellum, because you will find a lot of very cool things to do with it. So hope this is helpful for now. See you in the next couple of videos. Cheers.